All right, in this problem we have a single trig function and an angle. And keep in mind, if it says sine of theta squared, the implication there is that you are squaring the angle first and then taking the sine. That's different than sine squared of theta. That means you would take the sine of the angle first and square the result at the end. So in this case, the implication is square first and then apply sine. What we normally see, I guess, it would be to take the sine first and square the result. So I just want to be sure you're clear on what that means before we proceed. But generally, when we're doing u sub and there's a single trig function, and the angle is more complicated than just simply an x or just simply a theta, very often you're going to want to let u equal the angle here. And then du as a consequence, the 2 will come down. You'll have 2 theta and then tack on a d theta. So when we rewrite the integral, writing sine of u is really sine of theta squared. I can just put sine of u here, and I've already accounted for that much of the integral. Theta d theta is what I still need to account for. Well, theta d theta is built into my differential of u. All I have to do is kill off this 2. So I'm gonna call this 1/2 du is how I'd write theta d theta. So I'm going to put the 1/2 out front and, of course, the du inside. And then integrating this, I keep the 1/2. Integrating sine gives me negative cosine of u. And instead of writing u, I'm going to go back and put in theta squared. And that'll be true from negative square root pi over 3, which looks ugly but ends up being nice, to 0. So plugging in 0 gives me cosine of 0, which is 1. Plugging in negative square root of pi over 3, the first thing I do is square that. The square will kill off the negative, and it'll kill off the square root, so I will literally just have pi over 3 for my angle. And cosine at pi over 3 is 1/2. So we have negative half times positive 1/2, which should give you a negative 1/4 for an answer. All right, here we're given an acceleration function in miles per hour per second for a motorcycle. This is clearly not based on personal experience. We're going to calculate the integral from 1 to the 2 squared of 2 of that acceleration function, then describe what it means, including a label. And probably, hopefully you already have kind of a sense that if you integrate acceleration, you're finding something to do with velocity, because we have position as sort of the parent, velocity and acceleration. Differentiating takes you this way. Anti-differentiating or integrating is going to take you back up. So here we are at acceleration. We're integrating. That means we're going to end up doing something with velocity. And specifically, if you think about what fundamental theorem is, to evaluate a definite integral, you first integrate the function. Integrating a is going to take us to v. And then you plug in the upper limit. And then you plug in the lower limit. So you're literally going to have, I can already answer the context part. We are going to find the change in velocity in miles per hour, because that's my velocity label, during the time interval 1 till 2 squared of 2 seconds. So now we just have to come up with a number. So we're going to want to integrate this thing. I don't know why I'm rewriting it. Just seemed like the right thing to do. Are we going to need u sub here? Yeah, we are. There isn't really a major quantity going to a power. It doesn't appear to, unless you consider the bottom, t squared plus 8, is in fact going to the negative half power. Negative because it's in the denominator, and half because it's in a square root. So I'm going to let d equal the inner function of the denominator. Du then would be 2t dt. And rewriting the integral, if I want to kill off the bottom, I just have to say u to the negative half. Again, the negative puts me in the denominator, the half gives me the square root, and now I've accounted for that much. I still need to take care of 64t dt. And right here what I have is 2t dt. If I could just power this up by 32, I would have 64t dt, which would be what I want. So I'm going to do that. I'm going to multiply this side by 32 to get what I'm trying to kill off, and that means I would have to multiply the left side by 32 to balance it out. So the 32 I'm going to stick outside the integral, and then the du I will stick inside the integral, and now this equals the original function, except no fractions, none of that mess. When I integrate u to the negative half, I go up a power, so I'm at positive half, and I could put this over a half, but dividing by a half is kind of a silly way of saying times 2. So really I've got 2 times 32. I got 64, and then u to the half power means square root. I'm going to plug in what u really is, which is t squared plus 8. And we're going to evaluate that from 1 to the 2 square root of 2. Plugging in my upper limit, so squaring 2 gives me 4, squaring the square root gives me 2, 4 times 2 is 8, plus 8 is 16, and the square root of that is 4. Plugging in 1 for t gives me literally 1 plus 8, which is 9. It's inside a square root, so square root of 9 is 3. So 64 times 1 is 64 miles per hour, and that is our change in the velocity during that time interval. All right, here they want you very specifically to use this substitution. This is kind of a popular way of testing if you understand U sub on the AP test on a multiple choice version. They'd give you, a problem like this, and then tell you use U to represent some part of the integral. Then what would your new limits of integration be if you were going to do what we did in that second example where we converted the x limits into u values? So they're kind of forcing us to do that here because they're giving us the problem in terms of u, and then they want the limits of integration as well as anything that you'd have to stick outside. So we're just going to do the problem like normal and let the pieces fall where they may fall. If u is x squared plus 9, that would mean du would be 2x dx. So if I were going to rewrite this integral, I could take care of this much by just doing u to the half. I would still need to account for x dx, which is, hey, built into du. I would have to put a 1/2 out front to kill off this 2, and then I could keep du inside the integral. So that already tells me what c is. The number out front is 1/2. You'll notice everything else matches here. I've just got to convert my limits of integration into u values. So my old limits of integration were 4 on top and 2 on bottom. If I plug 4 into this function for x, I would get 4 squared is 16 plus 9. So the u value that results is 25. And if I plug 2 into this function for x, I get 2 squared, so 4 plus 9, and the u value that results is 13. So my new lower limit is 13. That's replacing the old 2. And my new upper limit is 25. That's replacing the old 4. So in context here, my a value is the lower limit 13, my b value is the upper limit 25, and my number outside is that constant that I had to pull out to get du to knock out the rest of the integral.